You have to correct this data for post-glacial rebound because these ice sheets are still deglaciating, especially in Antarctica. The Earth crust is still rebounding in response to that. And you have to take that into account to measure the change in ice mass. So that's one of the difficulties of this technique. So it's the best method to look at overall mass balance, but it's a short time record. We only have data since 2002, and you have to correct for what we call the post-glacial rebound. Now, the other technique, the third one and the last one, is to do the mass budget of the ice sheet. It's probably the most intuitive, but you look at what's coming in and what's coming out, and you see if the difference is 0 or positive or negative. What's coming in is the snowfall in Antarctica. And only since 2006 we have reliable maps of the snowfall pattern in Antarctic. Before it was done from surface measurements, interpolated over the whole ice sheet, and interpolated sometimes with some kind of voodoo rules. I mean, magic wonders. Because there's not a lot of data, and in particular, if you look at this map, a lot of the accumulation in the Antarctic is along the coast. As it turns out, a lot of the ice cores are not drilled in the coast. They're drilled in the interior. There's almost no data collected in the field in these regions. But anyway, these are produced from regional climate models. They're constrained by global climate models, and then they figure out how the mass is being redistributed inside the Antarctic. So that's the snow input. And then the output, this has been my line of work for the past 10 years, is to look at the velocity of the ice. You calculate how thick it is, because it reaches the ocean and becomes a float, so you can calculate the thickness from hydrostatic equilibrium, and you get the flux from that. And you compare that flux with the accumulation of snow in the interior over drainage basin. You see this glacier here is draining this whole area. So I calculate the amount of mass that falls into that whole basin, and I compare that with the flux on the periphery. And when you do that, you find that most of what we call East Antarctica here, the East Antarctic Plateau, is pretty much close to balance. The region that shows a lot of imbalance is the West Antarctic sector here in the Amundsen Sea. You see these big red blotches, and the northern tip of the Antarctic Peninsula. So this technique is best for explaining changes because you can look at the glacier speed up. But you're also comparing two large numbers. You're comparing the snowfall in the interior, a very big number, and you're comparing the output, which is another very big number, and you want to find a difference. So this technique is only possible because of satellites, because in the old days, if you had one measurement point of velocity and one measurement point of thickness and a few cores out in the interior, it was just pure guesswork to determine from that if the glacier was in balance or not. I have a couple of slides on the change in physical climate in Greenland. What's happening in Greenland in terms of air and ocean temperature? This is a record from a coastal station in East Greenland. You see these little ups and downs in temperature. There's a warm period in the 30s, 40s, and then a cooling in the 60s, 70s. This is in time where the ice sheet was close to balance, and we've seen a rapid warming since then, about 2 to 3 degrees. The one below here represents the temperature of the ocean at different depth. Different colors represent different depth, but we have the same thing. The ocean more or less follows what the air temperature is doing, and we've experienced pronounced warming of air and the ocean in Greenland since the 1980s. As a consequence of that, you see the melt area of Greenland in red, which has been increasing dramatically in 10 years. This is how much of Greenland is melting today. This is the Greenland mass balance. This is the input from snow in the last 50 years. This is 1957 to 2007. Not much of a change. And this is the runoff, the melting of the ice sheet. Not much of a change until the 90s, where you see this little increase in trend here in the runoff. And it's quite a big increase. The runoff increased 50% in the last 15 years in Greenland. So it's melting like crazy in Greenland today. But the snowfall has not changed very much, or when it changes enough to really excite the global warming skeptics. How about Antarctica? Antarctica is warming, and this is the results just published a few months ago, because they were able to go back to the 1950s and really establish a clear trend on air temperatures in Greenland. The records that were limited to 10, 20 years were not conclusive enough to determine what was happening in the Antarctic. And you find that most of Antarctica is warming, especially West Antarctica, which is a lower lying part of the Antarctic ice sheet. So it is warming.